Chapter 18, question 195. This is the molecule of compound M. Okay. Compound M has two functional groups. This one, okay, ketone, carbonyl group, and we have C double bond OO here, ester. So the question says that M reacts with HCN, ketone and ester. Okay, ketone will react with HCN. Okay, but ester will not react with HCN. Okay, right. Now, which statements about this reaction are correct? Number 1. A small amount of sodium hydroxide will speed up the reaction. Okay, now, the reagent used, normally we write reagent used to react with carbonyl compound will be HCN, okay, with a little bit of NaCN. Now, the reason why we must use a little bit of NaCN because this is a catalyst. So to talk about why do we need a catalyst, okay, I'll draw the mechanism, okay, to show you why do we need the NaCN. Okay, yep. So this is the one that react with HCN. This one no reaction, yeah. Others no reaction. So I'll put a partial charges here. This carbon is partial positive. Okay, this oxygen is partial negative. So it can be attacked by the nucleophile. Okay, now first, okay, we have the Cn minus from the NaCN. Okay, so this cyanide ion will attack the carbon. And then I have another arrow going to the O. Yeah, a bit messy here. Let me probably just erase this. Change it to a smaller writing. So this carbon is partial positive, right? This O is partial negative. Why is it not showing the line? Okay, right. So another arrow from the double bond, one of pi bond to the O. So later what we get is an intermediate. O now has negative charge. Okay, with lone pair electrons. Then we have C bonded to the new Cn, new incoming Cn. Okay, the rest are the same, right? Okay, after that, we have a HCN molecule. Now, because of the electronegative N here, so this N is partial negative, this N is partial positive. So the O with the negative charge and lone pair is attracted to the positive hydrogen, positive N, partial positive N of the HCN. So now attack this. Let's go to C. Okay, so at the end, we get our hydroxynitrile. OH, CN. The rest, no change. Okay, change a bit of this. Sorry, I have a bit of OCD as a chemist. Okay, right. Okay, now let's go back to the question, why do we need the cyanide ion? Now, HCN itself is actually not, I forgot the Cn minus. So this HCN is actually a very weak electrolyte, very weak acid. It does not dissociate that much. So we do not have enough cyanide ion in HCN if we only use HCN. So we need the cyanide ion to start the mechanism, kickstart the reaction. So we use a little bit of an ionic salt, sodium cyanide. Okay, so the sodium cyanide is an ionic salt that is easily dissociated into Na positives and Cn minus. So we use the Cn minus here, okay, to kickstart the reaction. So as long as you can add anything that can give you more cyanide ion at the beginning, that can speed up the reaction. So that's why this is called a catalyst, right? So statement 1, okay, let's look at statement 1. It says that adding a little bit of sodium hydroxide will speed up the reaction. So let's see, can this sodium hydroxide react with HCN? Let's write an equation, Na, okay, with HCN. So what do we get? We will get NaCN, okay, and H2O. Okay, so you see or not, this reaction will actually give NaCN, and then the NaCN is the one that gives us the cyanide ion. So adding sodium hydroxide will actually speed up the reaction because sodium cyanide will form. So let me put a tick here. 1 is correct. Number 2, the reaction is initiated by the transfer of a proton to one of the CO groups. Initiated, so this is the initiation of the reaction. So it is initiated by what? It is initiated by cyanide ion, okay, attacking the partial positive carbon, not a proton. You see, proton only comes in later, right? So number 2 is not correct. Let's look at number 3. Both the CO groups react with HCN. Okay, from the very beginning, I already put, ketone reacts with HCN. Another CO from ester does not react with HCN. So number 3 is also not correct. So the answer is D. Only 1 is correct.